Hello everyone, Steve Stufflola here from Erie Community College, south of Buffalo, New York. In a series of videos we've been taking a look at the newspaper printing advertising for full page, full color ads. And I have some data here from a company I was working for back in January of 2016. They were a newspaper printer using cold set web offset lithography. And this data analysis consists of two parts, histograms and time plots. So let's take a look at the histograms here. As you know, a histogram is a vertical bar chart that shows you the amount of variation. And what we did here is we superimposed the specifications from SNAP, S-N-A-P, which is specifications for newsprint advertising production. The target aim for black is 105, and the tolerance limits are plus and minus 5 points. That takes you to a low of 105 to a high of 110. And then we could calculate the percent that was in spec, that was 63%, and we could calculate the percent of product that was out of spec, both on the low side and the high side, or the light side and the dark side, and that was 37%. 10% was on the light side and 27% was on the dark side. The average measurement here was 107, and when you compare that, the average was 109 or almost 110, and when you can compare that to a target of 105, you can see that you're not exactly accurate. And the standard deviation here was 0.248, pretty large. And this histogram represents 308 measurements. Let's look at the yellow. Again, the target on the yellow is 85. We were 29% within specification, and 71% within specification, and 29% outside of specification, 16 on the dark side and 12% on the light side. You can see that the average is almost exactly where we want to be in terms of target, and the standard deviation is much, much better here. 297 measurements made here. Looking at the Magenta histogram, 336 measurements, and 54% were within specification, 46% were outside of specification, 10% were on the light side, and 36% were on the dark side. When you look at the average of 93 versus 90, you can see we're slightly shifted to the right, and the standard deviation is 0.08. Looking at the Cyan variation, 330 measurements. The target on Cyan using SNAP is 90. The percentage of the population that was within spec was 56%. The percentage that was out of spec was 44%, 10% on the light side, and 34% on the dark side. When you look at the average of 93 versus 90, you can see that we're slightly shifted to the right in terms of accuracy, and the standard deviation of 0.07 is a little on the high side. Now, the histograms are interesting information, very informative, very useful, but it doesn't tell you anything about time, stability. So now what we want to do is we want to take a look at the data plotted over time. So this was the composite data for the histograms. This is the composite data for the time plots, time series, and let's look at the individual data here. So this horizontal axis here, the x-axis here, is time duration. From the minute we got the color okay and we started counting sheets, the total press run was about 2 hours and 45 minutes. This is at 25,000 copies per hour. This vertical line here shows you shift change, and these gaps here show you that the press was down for some reason. May have been a web break, may have been a roller problem or a plate problem or something like that. So you want to be as close as possible to this horizontal center line, which is your target of 105. Now over time you should be getting closer and closer to this target line because you have more opportunity to fine tune the densities. Let's look at the yellow. Again, the total press run was 2 hours and 45 minutes. We stopped measuring towards the end for some reason. We had some press downtime here. This was a shift change. You can see a lot of these densities were light at the beginning of the run, but over time we got closer, right? And then towards the end of the run, we got darker. Okay. Let's look at the Magenta density data. Time, density, shift change, target, presses down, right? And finally, we can take a look at the Cyan data. Time duration, density, target, shift change, and press down. So here on the Cyan, it looks like we started early in the run being on the dark side, but as we progressed through the run, we got closer to the center line. So this is good results. All right, and again, if we wanted to, we could take a look at the actual data here, and we could take a look at the standard deviations. So for each color here, we can calculate the average, see how close it comes to the target. The difference between those would be the accuracy. If we know the tolerance limits, we can calculate the percent that was in specification tolerances and the percentage that was out, and the percent that was on the light side, the percent that was on the dark side, and we can calculate the standard deviation. And there's some other more sophisticated statistics here, but we don't need to talk about that now. Okay, so in summary, hopefully you have a good appreciation and understanding of what histograms are, vertical bar charts that show you the amount of variation, and you can superimpose the specifications, targets, and tolerance limits on them to calculate percent conformance in and out, and on the high side and on the low side. But the problem with a histogram is it doesn't show you anything about time. So with the time data, the time series, the XY scatter diagrams here, you can see over time what's happening to variation. Okay, have a good day now. Bye-bye.